Polynomial regression is a type of regression analysis in which the relationship between the independent variable x and the dependent variable y is modeled as an n-degree polynomial. In simple linear regression, we model the relationship between x and y as a straight line, while in polynomial regression, we allow for curves in the relationship. The degree of the polynomial n determines the complexity of the curve that can be fitted to the data. For example, if n equals 2, the regression equation is quadratic, n equals 3 makes it cubic, and so on. Performing polynomial regression involves estimating the coefficients that best fit the observed data. This can be done using methods like the method of least squares or maximum likelihood estimation. Polynomial regression can capture nonlinear relationships between variables better than simple linear regression. However, higher degree polynomials can sometimes lead to overfitting, where the model fits the training data too closely and performs poorly on unseen data. Regularization techniques like ridge regression or lasso regression can help mitigate overfitting in polynomial regression models. To perform polynomial regression, the data is first plotted and analyzed to determine the best fitting polynomial equation. The polynomial regression model is then trained by adjusting the coefficients of the polynomial terms to minimize the difference between the observed and predicted values of the dependent variable. The resulting equation can then be used to make predictions for new data. NumPy module has such methods to implement this type of regression: polyfit and poly1D. It is necessary to know how good the relationship between the values of the x and y axis is if there are no relationship. The polynomial regression should not be used to predict anything. The relationship can be measured with a value called the r-squared. The r-squared value ranges from 0 to 1. 0 means no relationship, and 1 means 100% related. Sklern module has a method r2_score which can compute this value. It accepts two parameters, y and a model. Practical uses of polynomial regression. Polynomial regression finds itself an important tool in real-world analytics. For example, economic growth modeling, climate change, healthcare. Healthcare data analyzing often resorts to polynomial regression. It is useful to predict disease trends.